Our planet is facing a massive plastic problem. Plastic is everywhere, in our homes, cars, and shops. We use it for food packaging, toys, and countless other things. Its convenience comes at a steep cost. Plastic doesn't go away. A single bottle can linger for centuries, unlike natural waste. Most plastic is used once, then tossed, yet away doesn't exist. It piles up in landfills or ends up in rivers and oceans, harming wildlife. Beaches are littered and sea creatures mistake plastic for food. The plastic we discard breaks into microplastics, tiny fragments that invade soil, water, and even our food. We've created a material the Earth can't digest, and now it's coming back to us. The scale is staggering. More plastic has been produced in the last decade than the entire previous century. Every day, more waste accumulates and more plastic flows into the oceans. Technology and laws have tried to help, but the problem persists. Yet nature may hold the answer. Sometimes solutions come from the most unexpected places. The planet is always adapting, and perhaps it's already working on a fix. Imagine if nature itself could help us clean up our mess. What if there were organisms that could break down plastic? This isn't just wishful thinking. It's happening. Scientists are discovering that nature is fighting back. The story of plastic-eating fungi is just beginning. These organisms could be the key to a cleaner future, but first, we need to understand how they work. The journey to a plastic-free world starts with a single discovery. Let's explore how nature is rising to the challenge. The answers may be closer than we think. In a landfill in Islamabad, Pakistan, scientists made a surprising discovery. Amidst heaps of garbage, they found a fungus, Aspergillus tubigensis. This humble organism was eating plastic, specifically polyurethane. Polyurethane is everywhere, from furniture foam to shoe soles. Normally it takes centuries to break down, but this fungus was different. In the lab, scientists watched as the fungus grew on plastic, sending out mycelium, thread-like roots. These roots released enzymes that broke the plastic apart. In just weeks, the surface of the plastic was visibly damaged. The fungus was turning pollution into food, using plastic to fuel its growth. This was a breakthrough, a living thing digesting a man-made material. Aspergillus tubigensis became a symbol of hope. It proved that nature could adapt to our modern problems. The discovery sparked a new field of research. Scientists began searching for other organisms with similar abilities. If one fungus could eat plastic, maybe others could too. The hunt for nature's plastic eaters had begun. This tiny fungus showed us that solutions can come from the most unlikely places. Nature's cleanup crew might already be at work. The challenge now is to harness this power for the greater good. What else could be out there waiting to be discovered? The story of plastic-eating fungi was just getting started, and it was about to get even more interesting. Deep in the Amazon rainforest, another discovery awaited. Yale students exploring Ecuador in 2011 found a fungus called Pestalotiopsis microspora. Like its cousin in Pakistan, it could eat polyurethane plastic. But this fungus had a unique talent. It could survive without oxygen. Landfills are packed tight, with little air, an environment where most organisms can't survive. Yet Pestalotiopsis microspora thrived, making it perfect for breaking down waste deep in landfills. It evolved in the competitive Amazon, learning to digest what others couldn't. This discovery showed that ancient ecosystems might hold solutions to modern problems. The Amazon, often called the lungs of the planet, was now offering a way to clean up our mess. With two powerful fungi found in vastly different places, scientists realized plastic-eating abilities might be more common than once thought. Nature was adapting to our pollution. The question became, how can we work with these organisms to tackle the plastic crisis? The answer could change how we manage waste forever. Protecting wild places might be key to finding more solutions. Nature's ingenuity was on full display. The race to harness it had begun. How do these fungi eat plastic? They use enzymes, tiny biological scissors, to cut up tough plastic molecules. Fungi are nature's decomposers, experts at breaking down wood and leaves. When they encounter plastic, they release enzymes onto its surface. These enzymes attack the strong chemical bonds, snipping long chains into smaller pieces. The fungus then absorbs these fragments as food, turning pollution into living tissue. Unlike microplastics, this is true biodegradation. Plastic is broken down to its basic components. What would take centuries in nature, fungi can do in weeks or months. It's nature's alchemy, transforming harmful waste into something useful. This ability makes fungi a promising tool for tackling plastic pollution. They don't just break plastic apart, they recycle it at the molecular level. Nature's solutions are often elegant and efficient. Fungi show us that even our toughest problems can have natural answers. Plastic pollution isn't just a land problem, it's choking our oceans too. In 2024, researchers in Hawaii discovered marine fungi that eat plastic. They collected fungi from sand, seaweed, and corals around Oahu. Over 60% of these fungi could degrade polyurethane plastic. Even more exciting, some fungi improved their plastic-eating abilities when trained in the lab. Their appetite increased by up to 15%. This opens the door to cultivating super strains for ocean cleanup. The research sparked global excitement. Scientists are now testing if these fungi can tackle tougher plastics like those in bags and bottles. The ocean may be developing its own immune response to pollution. Nature is not passive, it's actively adapting, even in the sea's depths. Marine fungi could become powerful allies in the fight against plastic waste. The future of ocean cleanup may be microscopic. Lab discoveries are promising, but can they work in real life? In 2025, a Texas startup launched the Digestible Diaper. Each diaper comes with a packet of plastic-eating fungi. After use, parents add the fungi which activate with moisture. The fungi grow through the diaper's plastic, starting decomposition in weeks. In lab tests, diapers turned into rich soil in about 9 months. This is a huge leap from the centuries it takes for regular diapers to break down. The company is expanding the technology to other single-use products. The Digestible Diaper is proof that we can design products to work with nature, not against it. It's a glimpse of a future where waste becomes a resource. Technology and nature working together can change how we think about trash. The revolution has begun one diaper at a time. To grasp the importance of plastic-eating fungi, we must face the scale of the crisis. Every day, 8 million pieces of plastic enter our oceans, like dumping a garbage truck every minute. The Great Pacific Garbage Patch, now 3 times the size of France, is just one of 5 major ocean trash zones. Plastic doesn't biodegrade, it breaks into microplastics, polluting even the most remote places. These fragments are found in Arctic ice, deep-sea trenches, and even rainwater. Harmful chemicals in plastics leach into the environment and our food. 1 in 3 fish caught for food contains plastic. We've produced more plastic in the last decade than the entire 20th century. Recycling can't keep up. Much of our recycled plastic still ends up as pollution. The crisis is global and growing. Our throwaway culture has left a toxic legacy. The need for solutions is urgent. Nature's plastic recyclers could be vital allies, but we must act quickly and wisely. The world is watching and waiting for change. Disposable diapers are a major plastic problem. A single baby can use thousands, each made with plastic that lasts centuries. In the US alone, 4 million tons of diapers are thrown away every year. Once in landfills, they take up space and leach chemicals and microplastics. Diapers also contain human waste which breaks down slowly and can create methane, a potent greenhouse gas. Every disposable diaper ever made still exists unless it's been burned. The environmental cost is enormous for a few hours of convenience. Biodegradable options like the Digestible Diaper offer hope. If widely adopted, they could prevent millions of tons of waste. Targeted, nature-based solutions can make a real difference. Plastic-eating fungi are exciting, but they're not a magic fix. Mycoremediation using fungi to clean up pollution holds promise, but it's not simple. Large-scale use requires careful research to avoid unintended consequences. Fungi work best in the right conditions, and scaling up is a challenge. The process, while faster than nature, still takes time. Experts warn fungi can help clean up, but they can't stop the flood of new plastic. The real solution is to reduce plastic use at the source. We must eliminate unnecessary single-use plastics and design for reuse. Fungi are a tool, not an excuse to keep polluting. Prevention is always better than cure. The story of plastic-eating fungi is one of hope and humility. Nature is not just a victim, it's a resilient, adaptive force. Fungi show us that life can find solutions to even our toughest problems. But we must become better partners with nature. Protecting biodiversity is crucial. The next breakthrough may be hidden in a threatened habitat. Investing in science and learning from nature's cycles is key. We must design systems where waste becomes a resource. Nature is offering us answers, if we're wise enough to listen. The future depends on this partnership. It's time to accept nature's help and do our part.